Hey class, so this video is to just go over one reaction, the Wittig reaction and the Wittig reagents. After talking to a few students, they wanted to see this again. So I thought I would explain this again through a video so you can look at it. So your Wittig reaction involves this Wittig reagent. This Wittig reagent has a carbon bonded to a phosphorus, which is bonded to three phenyl groups, which is benzene ring. And then you have this carbon, which is negatively charged, attached to two R groups. Now that R can be H as well. It doesn't have to be a carbon. It could be a hydrogen as well. So now if you're doing this reaction, typically this reaction is done on ketones or aldehydes. And this is the part of the molecule that you're most interested in. Without doing the mechanism, the easiest way to think about how this Wittig is going to happen is just basically cut the O off and add on the two substituents that's on the carbon. So if I was to redraw this, I'll draw it like that. So I just draw the double bond and I'm saying, okay, which two groups was previously on that carbon? Here you can see I have a ethyl group there and I have a hydrogen. So those are the two things that will end up on this, okay? So that's the little trick, right? Of course, we have to think about the mechanism, but that is just the easy trick to say, okay, hey, yeah, this is how this reaction happens, right? And as you can see, this Wittig, this is your nucleophile. Of course, that is still the electrophile. So let's go ahead and draw the mechanism. So this mechanism goes as expected. That goes there. Okay. And then in your next step, I just redrew this already. And this is attached to the PPH3, which is still positively charged. And then from this point, just look at negative and positive. Those two things are going to react and they're going to form a four-membered ring. And as we learned, we formed this four-membered ring. And we know from Orgo 1 that four-membered rings are highly strained, so it's not going to stick around like that. But the driving force for this reaction is the formation of the PO bond, which is a very strong bond. So you can see what's going to happen here, right? So those electrons from here go there, and then these go to form the new double bond. Remember, that's the new double bond that forms right here. That's what you're forming. And that's how you end up transferring those two R groups to the double bond. And then you have the O minus P bond that we're trying to form, that's very strong. And that's the driving force, right? Reactions happen because something is pushing it towards a product, and this is the product that makes it go. So let's look at it a different way. If I gave you this scenario, I say, you know, I have this ketone and I want to make this structure. Using a Wittig reagent, how would you go about doing this reaction? How I would look at it is that, oh, I see I have a double bond there, double bond there. So this is new. This is something that was not there before, that's there now, and the O is gone. So the way to use a Wittig to do that, I know, okay, I can cut that off, and this must be the part, right? And the H is not shown, but it's there. So these are the two things that I need on my Wittig reagent. So I know I'm going to use a Wittig reagent that looks like this, right? Where I have, this is the Wittig that I'm going to use for this reaction. So you should be able to tell me, okay, what do I use? Just look at what the new substituents are and put it on the carbon of your Wittig reagent. Now, the second thing that I want you to know how to do is being able to synthesize that Wittig reagent. So if I say synthesize this, get used to seeing it with or without the H, right? If I say I need to synthesize this, how would you go about synthesizing it, right? You need to have an alkyl halide with these two groups on it. Again, I want to emphasize the two groups. So that needs to be consistent across your reaction. So to make this, I need a alkyl halide that has those two substituents on it, and the two things that remain the same no matter what is that plus butyl lithium, right? That's going to give me this product that I need here. Okay, so you should be able to figure out what kind of Wittig you need. And secondly, if I ask you to synthesize that yelid, you should be able to go from the alkyl halide. Now, the H doesn't have to be there. That's just for emphasis, so I know I'm really transferring that H and whatever R group that's needed to the Wittig reagent that I need.